Hey, so here's a wee example of an array, and what we're going to do is we're going to just have a wee look to see how the algorithm for finding min works. And if you understand find min, it's a couple of changes, and you've changed the algorithm from finding the smallest to finding the largest, which is find max. So here's a wee array. It starts at 0, so it's actually got 7 people's IQs. So if I said, well, what's the size of the lowest IQ? You would just go through and say 70. Obviously, we need to be able to program a computer in order to do that. So there's a wee standard algorithm, which is essentially just a wee standard method that we can actually program in for it to achieve that task. So computers, if you actually get a computer to look through this array, it can only look at one value at once. So what the computer does is it looks at the first value, and it's the only value it's seen, so it just says, well, that's the smallest. Okay, so right now that's the smallest IQ. It then compares what it's got as the smallest with the next one along, so it looks at the contents of the next element. These are known as indices, right? So index 1, so I'll look at the contents, and if it actually finds that that number is actually smaller than what you've got saved as a min, it just saves that over min. Okay, so that is now the min, and it goes all the way through for the rest of the array until it will actually find the smallest one. Okay, so it takes the first one, saves it as the smallest, and if it finds one that is smaller than what it's currently got as the smallest, it then just replaces it. Okay, so what we'll do is we'll use a wee table. I'm going to just change that so it's min instead of max. And with this wee table there, and we'll write down the standard algorithm, and hopefully it makes it a wee bit clearer. Right, so if we have a wee start now, if we look here, what we've got is we're going to look at index at position 0, right? So position 0, the value is 89. And the first line of code is just what we say is we'll just say, we'll call it lowest. Okay, so we'll just say lowest equals, and we'll just say IQ 0. Okay, so essentially what we're just saying here is set lowest to the element index 0 in this array. Okay, so you might also say you could write it as set lowest to first element of the array, but this is just basically saying that the lowest, so I'll just say call this lowest, that currently is 89. And then what we need to do for every other element, we need to compare it with the lowest. And if we find that there's a number that's actually even smaller, we then need to replace that as lowest. Okay, so what we can say is then loop for rest of IQ array. And all you're saying there is for the rest of the array, you're going to do a certain task, okay? So I'll use another wee pen. So what we can say is we can say, well, if the value stored in lowest is actually bigger than what we are now looking at, so IQ, just call it index, you could call it counter if you wanted, then do the following. Okay, so if what we're currently looking at, which index equals 1 now, in that value, okay, so all that's saying is if 80 is actually smaller than what we've got as lowest, well, it is, we then need to tell it just to save that as lowest. Okay, so it goes then lowest equals IQ index. We can do end if. Okay, and I'm just indenting it to make it a wee bit easier to read, and I'll just use the same colour to we can just say Next. Okay, and what we've got now is we've now got a piece of code that takes the first value, saves it as lowest, and then if it actually finds what it's thought is lowest is actually bigger than what it's now looking at, so obviously that number is smaller than it, then set lowest to that new value. And it just keeps on looping through until it comes to the end of the array. So if we actually work on this principle, so we can say, well, that's now 80, right? If you now look at index 2, which is 90, so that value, okay, is 90. Now, I'll move it so you can see it. Now, if we look at 90, is 80 bigger than 90? No, so 80 is still the smallest, okay? And then looks at index 3, which is 91. So, is 80 bigger than 91? No, it's not, so 80 is still the smallest. Okay, it then looks at index 4, and that value is 70. So right now, lowest is still 80, okay, so that's still 80. So is 80 bigger than 70? Well, it is, so that is why lowest now equals to 70. Then it carries on through, we've got 5 at 77. So is 70 bigger than 77? No, it's not, so that remains the lowest. Then it goes to index 6, which is holding 92. Lowest is 70 greater than 92? No, it's not, so 70 is the smallest, okay? So it's a wee method that you can use. If you wanted to actually print out the smallest, okay, to make sure you get that mark, you actually need to then actually at the end and just say display lowest. Now, say they wanted you to actually change it, so you're not wanting the lowest, you're actually wanting the highest. What you'd have to do is you'd have to call that highest. So you'd have to score that out. Have to change that to highest. So you'd have to change the variables to highest. Obviously change that to highest. So every time you saw lowest, it's now highest. Same with that. And there's one other wee change in which you change the direction of the sign. So that would mean if you've got a large number and if you're finding that that number is actually smaller than one of the other numbers in the array, then it can no longer be the highest, so it needs to take that number and save it as highest. So you could even recreate this table as practice, so it'll be index value, and this time put max and just call it highest, and hopefully that will allow you to work your way through the algorithm. Okay, so there's different ways of writing it, but as long as you're identifying what you're having as the initial value for the variable, and then you go through using a loop to go through each index. So it counts through each index, and for each index you're wanting to compare what you've got as, for this instance, the lowest with the number you're looking at, and if it turns out that number's actually smallest than the lowest that you've got saved, you just save that as the new lowest. And you'll find that every year they ask a similar question. So hopefully that's been of some use.